Hello and welcome to Semgrep Rule Writing 101. I'm so glad that everyone is here. I hope you enjoyed that little intro. It's a traditional Scandinavian folk song. So today we're going to be talking about Semgrep rule writing, and I really hope that all of you know kind of what that entails, but if not, fear not, because we're going to get into that. So first off, I've got something really important to share with you, and we're going to dive right into it. He survived. What is this? What happened to this person? Well, they fell and they're okay. Don't worry about it. But the finest of parkour runners know the importance of guardrails. Now, you may have heard of this term called security guardrails, which is something that tries to keep our code safe, our applications safe. The only difference between a security professional and a parkour runner is that both of us know that secure guardrails are essential to make sure that we don't hit the ground too hard. So the idea of secure guardrails meaning that we want to make sure that our applications are secure, that they're safe, that the default is to have secure practices as opposed to something that's opted into. We want to guide our developers into secure practices, no matter what. That's what we're all here to do, right? So we're going to try and learn how to do that today in today's webinar. The thing about security guardrails you have to realize is that it's not just for the convenience of developers, it's for all of us, right? How many hours do we have in a day? 24 hours in a day, 7 days in a week, 5 working days in a week, and then however many weeks in your year. But it doesn't matter because there's so much noise you have to get through. We're all very, very familiar with the fact that between audits and pen tests and having to triage vulnerabilities, there's so much noise, there's so much stuff you got to do in the modern age. I really like this quote from Semgrep CEO Isaac Evans, where he said, "A gloomy security engineer at a large bank once explained that if development stopped today, he had calculated it would take over 100 years for them to get through the vulnerability backlog." Do either of you, any of you, have 100 years in your back pocket? I sure don't. I don't think that any of us do. Well, there's no time to get through the backlog and to constantly fight fires that are only expanding as the surface of our applications, as the surface of our vulnerabilities increases. So this attack surface is broadening. We cannot spend time just dealing with stuff after the fact. So what can you do? What can you do without guardrails? There's very little you can do once the car, metaphorically, has already driven off the mountain. They say that the definition of insanity is doing the same thing over and over again, expecting a different result. It's not enough to keep chasing vulnerabilities. We have to come up with remediation that extends into the future, because we don't have enough time and the backlog is only growing bigger. We have to make sure that we're not just winning the current fight, but all future fights. That's what secure guardrails, that's what enforcing secure practices with automated rules like Semgrep rules is all about. Ender Wiggin, protagonist of Ender's Game, if you've read that novel, said, "Knocking him down won the first fight. I wanted to win all of the next ones too." He was a big fan of secure guardrails. So let's stop the problem at its source. Let's build the guardrails that will make sure that our organizations, that our applications, that our code, our programs will maintain within the secure, line, the secure region, and not veer off into insanity. Okay? I've not introduced myself, but hello, my name is Brandon. I'm a program analysis engineer working at Semgrep. I gave a little bit of a brute force kind of like quick intro into everything because I like to talk about all of this secret guardrail stuff, but let's address logistics real fast. I'm really happy that all of you are here. This is a rule writing workshop, which means that we'll be talking about how to write Semgrep rules for the purpose of secure guardrails, like I've mentioned earlier. At times, I will be talking about technical things about Semgrep's engine. At times, I will be showing you syntax and ways to write these rules in our online playground. If you have any questions at any time, feel free to put into the chat, or you can also unmute your mic and talk to me as a real human being. There's only 30 of us in this room. That is a perfectly manageable number. If you would like to talk to me like a real human being, that is okay. If you would like to chat, that is also okay. But I'm not super checking the chat, so it may take me some time to get you a question. But please feel free to ask. So I'm a program analysis engineer. That means that I'm a specialty. My specialty is in programs and in analyzing them, kind of compiler-based stuff. I've been at Semgrep for about 3 years, and previously I was a guest lecturer at Carnegie Mellon University, where I taught functional programming as a topic. You probably know what Semgrep is. I probably don't have to tell you, but we are a software security startup and application security platform. We want to make sure that developers can find and fix security vulns, and we want to make sure that it happens at least friction to the workflow, because we can't stop people from shipping. Our mission, profoundly improve software security. Or in other words, our mission is to make it cheap, to make it expensive to exploit software, or if you wanted to put it a slightly different way, we want to prevent people from shooting themselves in the foot, which is really all, like a large portion of the security game is make sure that people cannot do things that would cause them to have later pain. All right. So if people are okay to type so in the chat, I'd really love to hear, like, what does everyone here do? Is everyone here like a security engineer? Has everyone here heard of Semgrep? And in particular, I'm really interested in, has anyone here already written a Semgrep rule? I would love to hear from people whether or not they've already written a Semgrep rule before. Cool, thank you for your first response, Milland. Really appreciate that. Okay, never written a rule, that is A-okay, because that is exactly what we're here to do at Rule Writing 101. Does anyone else here want to pitch in? Have written a rule? Cool, okay, thank you, Steven. Right. Okay, I would be, you know, a little mystified, I guess, if someone said that they were like a flower bed, like gardener or something. I would wonder how that would happen. Team has written a few rules. Okay, cool. Great. Okay. And I know that everyone's coming from varying degrees of familiarity with writing rules, so we're going to hopefully ameliorate that today by learning how to write rules together. And have to write another rule this week. Okay, Daniel, there will be plenty of time to do that, and we have office hours afterwards if you have any questions. So I'm excited to hear what your use case is. Okay, cool. Right, long backlog. Yeah, that's that backlog I'm talking about, Craig. That's that, you know? Yeah. So maybe one day we'll be able to write Semgrep rules that write Semgrep rules. Okay, sounds good. So it sounds like we have a mix. We'll get right into it, and if anyone has questions based on, you know, differing levels of familiarity, please feel free. So first off, let's get started with some conceptual fundamentals. I got to tell you about what Semgrep is before I can tell you how to use Semgrep. So we're here because we're interested in software security. And broadly, what that means is we want to make sure that undesirable stuff in programs does not happen or is minimized wherever possible. So for instance, I might tell you that this takes the form of like a logic error. Let's say that you call foo, it takes an int, and you pass a string. Boom, you have a big mistake on your hands. That's a logic error. You shouldn't have done that. Code smell. Maybe your organization has, migrated from logger.info to like a brand new in-house logger kind of mechanism. And anytime that you use logger inside of your code base, that is actually a code smell, and you should probably not do that. And a human kind of has to look over your code and tell you, hey, you used this wrong thing, like maybe you should fix that. That is another thing that maybe could be automated, could have Semgrep do it. Or, as I know all of you are very interested in, security vulnerabilities. This is the money. This is the gold, where we want to catch all of this too. We want to make sure that we don't have SQL injection, cross-site scripting, broken authentication, all these valid avenues of attack. So all of these are fair game for things that we want to find and fix, and that is kind of our mantra for today. The two things you want to remember: find and fix. Our weapon of choice is static analysis, which is the art of analyzing programs without ever running them. So I'm like kind of an expert in static analysis. I know a little bit about static analysis, and that is pretty much all that Semgrep does, is it scans your code without ever running it, and it tells you where the bad stuff is. I have a list of some things about Semgrep that I think are cool. You probably know some of these or most of these. We're open source. We have community contributed language support. You can look at the code that I push every single day at github.com/semrep/semrep. It's customizable, so people always ask me, what does Semrep bind? I always like to tell them, Semrep binds whatever you like. We have a query language that Semrep uses, which is the Semrep rules that we're here to learn to write. And what that means is that you can write your own custom queries to tell Semrep what you want to bind. So it's customizable in that respect. Semrep is multilingual, unlike me, in that it is able to speak more than one language, and it actually supports over 25 at this point in time. So all of your standard, like your Python and Java and JavaScript and TypeScript and Java and Dart and Flutter and everything, and Apex, whatever, what have you. Usually, Semrep works with it. Semrep does not require you to build anything, physically or otherwise. So we only need source code. We scan source code and then we don't run it. And then no DSL. This is an idea that will come up later today in the webinar, but Semrep patterns look like the code that you're targeting. So you don't have to browse a bunch of documentation to necessarily look at syntax. All you need to be able to do is read and write code in the language you want to analyze. So if I want to analyze Python, I just need to know how to write Python to write a Semrep rule. pretty much. Okay, and this is a really important idea, and we'll go more into that as we go along. Here are some links. I realize none of you can click on these, but they exist. So we are in Brew, we have an open source repo, we have a VS Code extension, we have a rule registry, which is where all of our rules live that you can go and find, and we have a docs page, which will show you all of the place where our documentation on how to write rules lives. Okay, so I can send out a copy of these slides after the presentation if anyone would so like. Cool, but let's move on now. Okay. So first, I got to give you the 5,000-foot view of what Semgrep is. So the real pipeline you need to be aware of is we go from code to AST to analysis. I would actually be really curious to hear if anyone here has heard of ASTs before, are familiar with ASTs, if people would like to say in the chat. I think I might be able to do a poll, but I don't know how. I got a yes from Craig, nice. Yeah, okay, I don't know how, but if people would like to shoot that, that's kind of interesting and important because having an understanding is helpful. It is by no means necessary because kind of the point of Semgrep is that you shouldn't have to think about the ASCs. Okay, that's a no worries. We can work through it either way. So the idea is that we take your code, which looks like, maybe this Python program, b equals 1, def boo, which adds a and b. And all it does is it takes that code and it turns it into an intermediary tree called an AST, an abstract syntax tree, which is a representation of your source code. And then it runs analysis on it. This takes a couple of forms, but it does things like pattern matching, IL translation, taint analysis, concept propagation, a bunch of words. You don't need to know what they mean, but know that there's a bunch of magic that happens after the fact when we turn it into an AST. And the reason I'm telling you this is that knowing what Semgrep does helps with writing the rules if you know what is going on in the engine, because sometimes the engine can behave in ways that you don't expect. But it's easier if you already know what the engine does. Okay, so I want you to consider the program that we saw on this previous page. This is b equals 1 def foo. We can consider this as kind of a tree or kind of a thing of two parts, right? Because we have one declaration, which is b equals 1, and we have this function declaration, which is def foo. So if we wanted to notate this program in kind of a hierarchical structure, I would say that we have like one big parent, which is like the statements node, let's call it. And our left child, our first child, is the b equals 1 node. It's the statement. And then the second child is the function def foo. And if you squint your eyes and you look at the colors, the yellow here corresponds to the yellow node here, and the red corresponds to the red here. The colors are important because we say that each of these nodes has what's called a range. A range is a contiguous segment inside of a text file. So what I mean by that is it's like this thing that I can kind of like highlight with my mouse. This is a range, and it's all of the red stuff that's currently highlighted. And this range belongs to this node right here. So this node has the range of this red stuff, and this yellow node has the range of this yellow stuff. Okay? I don't need to treat it more formally than that. It kind of just has that kind of intuitive notion, if that makes sense, that every single node has the range of its constituent parts. Okay? But this is going to be very, very important for us when we write rules, because this is all that Semgrep is turning programs into nodes and trees that have ranges, and then obtaining those ranges and combining them. Okay, this will make more sense when we get into the actual Semgrep rules in a bit. Okay, but the thing I showed you here with b equals 1 and def foo, return a plus b, this is actually not the highest, lowest granularity we could possibly have. Okay, we could actually have more because we could decompose the yellow node into other stuff, right? The yellow b equals 1 is actually made up of two parts: the b, which is the identifier we're assigning to, and the 1, which is the right-hand side. And I might say that this red node, the function, is made up of a few things, like the name of the function, the arguments it takes in, and the body of the function, which is the return a plus b. And the return a plus b may itself be something that's composed. But basically, I'm trying to show you, it turtles all the way down. All these trees kind of decompose more, and they break into smaller and smaller chunks, where each of these chunks also has a range. The b has the range of this green, the 1 has the range of this blue, the foo has the range of this orange, the a has the range of this purple, and this a plus b has the range of this blue. I'll take questions now. Does this make sense to everyone what I'm saying? I don't need you to be able to do this by hand yourself, but this is what is happening at the base level of Semgrep's engine, is that we're breaking this program up into this AST, and it has these ranges. Does that make sense to everyone? Is that fair to say? Cromulent, if you will. Cool. Can I show why this is preferred over other engines? Steven, if that is okay, I'd love to answer that at the end of the presentation. I think it'll make more sense once we talk about these Semgrep rules a bit more. But that's a very good question. Don't let me forget about that one. I would love to talk about that. Okay, cool. Thank you all for your responses. Let's move on then if no one has questions at this time. So, this is our pipeline. We take the this program, we turn it into this yellow and red node, then we break the yellow and red nodes into their own small nodes here. And it's hurdles all the way down, it's ranges all the way. Cool? Cool. All right, I mentioned to you Semgrep is about matching nodes and obtaining ranges. Let's suppose that we are doing something where like we have a bunch of prints in our code base and we don't want the prints there, okay? So this could be our program. And one way that we can find all of the prints is we could use grep, or we could use Control F to find the prints. But it's not going to work properly. I wonder if someone could tell me why that is, either out loud or in chat. Like why is grepping or Control Fing for print probably not going to do exactly what I want it to do if all I care about is getting rid of these calls to print? I think this is a pretty good question. Why do I care about why does grep and Control F not quite? Is printed can cause conflict. Comments, string literals, exactly. In another word, we could get false positives. And false positives, by the way, should make you feel like this. It is the terror of a security engineer's day. It is awful. It is the ghost in the closet. Oh, I forgot to do this thing, by the way, which is that it is awful. We do not want these false positives in our program. So what can we do about it? Well, okay. We have to kind of get rid of these false points where they have grep. So print shows up here in this comment. It shows up here in the isPrinted identifier. It shows up in this string literal here, which is like printed now. It's a lot, and I don't quite like that. So Semgrep is going to let us bypass that and actually find the prints without getting these false positives. Okay. In another word, we can say that grep is not semantic. It just looks at the text. I don't want to just look at the text, though. Semgrep stands for semantic grep, if you didn't know that. It's a code searching tool, and it's aware of the underlying structure, the AST. So, Semgrep is made up of things called patterns and targets, okay? I'll show you how do you put them in the Semgrep playground, which will be how we actually run queries against programs. But for now, let's just do it in the slides. Will we get these slides? Yeah, Ricardo, I can put them up after the presentation for sure. Yeah, good question. So let's consider the following example. This thing on the left is what's called a Semgrep pattern. It is just kind of like text that like Semgrep understands. And it looks like a Python identifier. That's important. Okay, patterns look like some Python code for a Python pattern. So we're going to use this pattern print against this code. And let me show you what happens. It's only going to match this, and it's only going to match here. It will not match print. It will not match isPrinted. It will not match printing. It's not a matter of just ignoring the comments and string literals. We also didn't match this identifier, right? Because we were looking for an identifier only called print, not any identifier that contains print as a substring. Okay? And if it seems like magic how it does this, I'll tell you exactly how it does this in a second. But the point I'm trying to tell you is this is what Semgrep does. It's what Semgrep's good at. This is kind of the cool thing that we're going to be able to do with Semgrep. Okay? So, whoa. A lot of things just came up on screen. What just happened? Let's figure it out. So, I went through the same AST process that I showed you earlier with this program up here. This print example with isPrinted and print. I want you to squint your eyes and look at this tree at the bottom right. And if you squint your eyes and you think about it and you kind of use your intuitive judgment, I think that we should find that they should look pretty similar. Why? Because this program up here is really three things, right? It's a call to print, it's a call to isPrinted, and it's a call to print. This tree says it's made up of three statements. One of them is a call of print to the string hello world. One of them is a call of isPrinted to the literal true. And one of them is a call of print to the string printing. Does that make sense for everyone? Like, I think that if you kind of look at this and you think about what this program is and represents, this data structure I'm showing you, this tree, really kind of codifies the same information. Okay? I think that's something that's cool about it. And another cool thing is that if we try to match what's called running a rule against a target, a file, a code file, that's called matching. If we try to match this pattern to this target, here's what will happen. We will get match here at print and match here at print, and we see that the borders of the nodes that we match are also similarly in gold. Now, why is that? Why did we match this but not these three nodes, which were actually false positives in the case of grep? Well, the reason why is because we do three things. So what we do is we parse the pattern to an AST, which is this node here, this purple guy, this hexagon. We parse the target, the code file, to an AST, which is this big guy at the bottom right. And then we match them against each other. So we look at, are there any nodes on the right-hand side that look like our node on the bottom left? Well, let's see. This print looks exactly like this, so yes, that's a match. This print looks exactly like this node, so that's a match. Hello world does not look like print. Is printed is the same color, but it doesn't look like print because it's different text inside, so we don't match. It's just as simple as that. We turn them both into ASCs, we match them against each other, and the stuff that looks like each other matches, survives, gives us matches at the ranges of these nodes. So the reason why this code is highlighted is because this yellow is the range of this print. Any questions about this? This is, I think, like the most conceptually important thing to realize before we actually begin writing Semgrep rules, which we are about to do. Conceptually, like turning the pattern into an AST, turning the target into an AST, and matching them against each other, ranges, anything about that, I will take questions. And if there are not questions, you may forever hold your peace until the next time that I ask for questions. All right. Seems like I don't got anything so far, so I'm glad that everyone's following along. You guys are so smart. Wow. Cool. Okay. If we move on, we're going to talk about the basics of patterns. So I'm going to show you the Semgrep playground. So if we go to semgrep.dev, oh, do I have a question now? Is scoping the same as the color matching? The color matching has to do with the kind of node that it is. So for instance, if we go back and look at here, identifiers are purple hexagons. String literals are blue hexagons. And Boolean literals are green hexagons. The colors are arbitrary. This is obviously an artist's mind rendition, but the idea is that they're different kinds of nodes because one of them is a identifier, one of them is a string literal, and one of them is a Boolean literal. And this is like more or less pretty much exactly how the code works at the end of the day, is that it kind of separates them by this. Yep, good question. Cool. Okay, so if we go to semgrep.dev, we can scroll past this and we go to products. We go to products, and then the bottom, at the middle right, we see playground. This is where we're going to go to write our rules. And in fact, this is exactly the rule that I just showed you. Okay, we have the print hello world, we have is printed true, and print of printing. Sorry, this is the target. So this UI is going to be the way that we write Semgrep rules together, okay? This pattern block is where we put in our patterns. So to do the example I just showed you, what I would do is I would write print here. I would click the run button at the bottom right, and then true to form, just like I promised you, we're going to get two matches, one here and one here. And if we scroll up here, we can see, oh, look, we found a match on line 3 and a match on line 8. So if you want to actually try out this thing for yourself, you can go to the Semgrep dev playground and try that. If you want, I can short circuit you. Oops, I can short circuit you to this link. I can give you this link if anyone is really interested in trying this particular example. And actually, this might be helpful because I want you to know how to write rules, which means knowing how to use the UI too. So if you scroll there, you should be able to see that there's like a to-do here, and it's as simple as replacing the to-do with the identifier print and clicking run. Cool. And note that if you are to do this, we can also change this up. If I did is printed instead of print, what do you expect would happen? Well, we're actually going to match only this is printed identifier and not the individual print identifiers themselves. So this is actually desirable behavior from us that we want to see. So hopefully through seeing these runs of the Semgrep engine, it is a bit more intuitive over what it's doing. This is letting us match only the identifier is printed. Cool. And then I should also tell you about the comments that are in the target. This guy on the at the right. Sorry, I actually should fix this. So you might see that there's a comment here that says hashtag rule ID print example here. What this means is this is Semgrep specific syntax. If you leave a comment that says rule ID colon and the name of the rule, which is here, which is print example, it actually makes it a test case. It means that you are expecting a match on the next line. So this means that this current file is expecting us to match on line 3 and to match on line 8. It means to match on the next line. Okay, it's not like I'm on the same line. So is printed, we see these 2 red boxes because our test failed because we're supposed to match on this line here, line 8 and line 3. So if we change it back to, and that's because we changed it, right? So if we change back to print and we run the rule, we should actually get some green boxes because we managed to successfully print on this line and successfully match on this line and successfully match on this line. And I should show you the other way to do this is that if you want to specify that you don't want to match, that it's only correct if you don't match on the next line, you use hashtag OK. You leave a comment that says OK colon and the name of the rule. So it says, so for instance, if I did this, this would also be correct because we have an OK on line 10, which means we don't want to match on line 11. But if I change this pattern to don't match, we are going to match on line 11, which is wrong, and so 10 will complain at us. Line 10 will complain at us with the red box because we did the wrong thing. How is commented code being ignored? Semgrep is semantic, so it is fully agnostic to things that do not have semantic meaning, including comments. So that means that Semgrep does not see comments unless you use other special features we haven't talked about yet. But in general, Semgrep ignores comments because it's not relevant to the actual code, and Semgrep searches code. If that makes sense. So the commented, and this commented code, by the way, is only for the playground. It's only for if you're like writing a rule and you want to write tests for your rule. Okay, this doesn't need to exist in like your actual code. But yeah, good question. Okay, if that makes sense about these rule IDs and OKs, this will be important because this will help us understand what we want to match and not match in our future exercises. Okay. But we have kind of a bug, right? Because we only want to match calls to the print function and not the identifier print, right? So like, for instance, if I did print against this target, this rule code file, we would match this call to print, but we would also match here. This is not a call to print. This is just us aliasing the name print. Do you see the difference? Like, let's say that we have a critical bug that only comes up if you like use like printf or you call the function print. This is not a call, this is just us mentioning the identifier print. So the mantra of Semgrep is that patterns look like code. So if we want to match a call to print, the idea is that we should write something that looks kind of like a call to print. And let me explain to you what I mean by that. So this next thing I want to show you is something called the ellipsis. This is one of the few things of special Semgrep syntax you need to know. It's interleaved with the actual Python syntax though. What I mean by that is anywhere that you could put something in like an ASC node or like an element of a program in a Semgrep pattern, you can also put a ... which is the Semgrep ellipsis. And the idea is that a Semgrep ellipsis is a placeholder and it matches 0 or more occurrences of something, either parameters or arguments or statements. So if I wanted to match a call to print, I would write a call to print as my pattern, but instead of putting any arguments, because I don't know what the arguments are, I want to match any arguments, I would put a ... The ... means I want a call to print, but I don't care about the arguments. Could be 0 arguments, could be 1 argument, could be n array many, but it will match all of them. And if we were to run this in the playground, we would see that this pattern would actually only match here, because this print right here is not a call. It's just a mention of the identifier, right? And the important thing also to note is that's interesting is that our match has gone from just this range to this range, the range of the whole call. And that's because we matched the whole call node, not just the identifier. Okay? It should make sense if you're kind of able to squint your eyes and visualize the tree that I was talking about earlier. We're matching the entire call because we said we wanted to match something that was only a call. Okay? So this ellipsis will let us do that. And we'll look at a few more examples of how we can use this ellipsis in a second. But does this make sense to everyone? And I'm counting on you to speak up if something doesn't make sense, because only you can tell me if that's true. Give you maybe a second to think about it while I drink some water maybe. Cool. Thumbs up, and that is also a perfectly acceptable answer. Oh wait, let's move on. So, oh yeah, I wanted to tell you also, the dot 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 lets you match any number even 0. So like if this was our rule code file on the right, print dot 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 would match a print with no arguments, it would match a print with 1 argument, or it would match a print with 2 arguments. And these are 3 separate matches, not one big match. Okay, that's important to know too. And I've given you a haiku about it. No matter the count, when up against arguments, ellipsis matches. So think about that for a second, why don't you? Okay. I kind of explained this earlier to you, but I want to clarify why Semgrep is producing these matches. So when I turn the pattern print left paren dot 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 right paren and this program that has 3 prints, when I turn those into ASTs, I get these. I get a call of print to the lone argument dot dot dot, and dot 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 has this like kind of liney diagonal flavor to it because it's special. It's really special. Semgrep thinks that it's special, and the actual program that we have is made up of 3 statements. One is a call of print to 1 argument, one is a call of print to no arguments, and one is a call of print to 2 arguments, okay? But if you squint your eyes and look at this, actually, because this dot 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 kind of absorbs any number of arguments, these actually look really similar. So if I literally if I were to be able to like use GIMP to copy paste this pattern AST out and superimpose it over each of these call nodes inside of the target AST, it would look similar. That's what I mean by matching. We're going to go and look at if the pattern overlaid over the target AST matches at any subtree. And because of this dot dot dot, it does, because dot 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 is special and it can kind of absorb any number of arguments. Cool? There's a lot of vibes going on here, right? But like, in a way, I think this is a good thing, because Semgrep kind of like makes intuitive sense in that way. Okay, and I kind of already mentioned this, but we match the whole call node because we match the whole call node, right? Our match is to this entire call, which has the range of the print and the range of the 1, as opposed to the range of just the print, which we saw earlier when our pattern was just print. So it's all nodes and ranges? Yes, it always has been. Okay? I don't need you to be able to picture the trees in your head. I just want you to know that at the end of the day, all we're doing is matching nodes, and those nodes have ranges. That's all I need you to know and all I need you to think about. But it doesn't need to be much more complicated than that. Okay, so we're going to do an exercise together, okay? And hopefully this will make everything make sense. I want to use the ellipsis, and let's say that we want to disallow certain deprecated or dangerous functions. Like we want to make sure that our developers don't use exec, because using exec is kind of dumb and silly, and they should probably not do that. Well, let's see here. So let's do this exercise together. So I have an exercise where I import exec as definitely safe function, and I call definitely safe function with user input. Side note, that's probably pretty dangerous. So let's maybe not do that, okay? Or we call exec with like no arguments, maybe, I don't really care. Or we call exec with like 1 argument, okay? All of them are probably like kind of a little bit dangerous, right? So let's write a pattern that will let us match all of these uses of exec. Would anyone like to throw out a wild guess as to what we would write here? It's going to be a single one-liner to match all of the calls to exec, to make sure that we can, our developers will not be able to push exec. Anyone have any thoughts? If I had candy, I'd be giving it out to reward answering questions. All right, I got some answers. Oh, I got a bunch of examples. Oh, wow, you guys are on it. Yeah, everyone wrote exactly the right thing. That's crazy. Exec, left paren, dot, dot, dot. And you might be thinking, does it work with the definitely safe function? Well, lo and behold, boom, 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 it does. And that's because Semgrep is smart. And Semgrep understands things like aliases. So even if we import exec as something else, we can find it. And I would like to let you know, like, this is a markedly better approach than regex or like grep. Like imagine if we grepped for exec left paren. We wouldn't find like this, right? Because it's not exec left paren, it's definitely safe function left paren. So this is where the semantic grep comes in. We understand the program, we understand when you alias stuff, we understand when you call certain functions, okay? That's the idea that I'm trying to get across here with Semgrep. I think that's pretty cool. So congrats to everyone, we passed the exercise. You have proceeded to level 3 maybe. The other thing Is it the general approach for all SAS tools to understand the semantics of the code? I would say so, yeah. Every SAS tool kind of needs to understand what the code is really doing and what the ASCs. Yes, ASCs are the bread and butter of SAS tools. You simply it's been the standard approach in compiler technology for like 50 years, like more probably. So this is how people have been doing program analysis for decades. Yeah. I would be very surprised if there was a single SAS tool out there that didn't use some manner of ASCs or call graphs or whatever, what have you. Yeah, good question. Okay. The thing I want to get across to you is that ellipsis, unlike friendship, is not magic. Okay? And what I mean by that is that you cannot do something like this. I see people do this a lot when they write rules. They write def ... and they expect this to match any function. Okay? This does not match any function. Okay? This is a regex way of thinking. The point is that Semgrep compiles your pattern to an AST, and ... is only allowed wherever you could either put a parameter, an argument, or a statement. Okay? It means that you can't put it and just match any like text. We're not talking about text. Semgrep is not concerned with text. Semgrep is concerned with like ASTs. And what I mean by that is then in def ... is there any Python construct that looks like def ... where ... is like arguments or parameters or statements? The answer is no. The pattern is invalid. Patterns have to parse as Python code. So what I mean by that is let's say that we wanted to do this and match. I'm telling you that if I did this, it wouldn't work. But here's what I could do. Or I'll show you what I'm going to do next. Actually, I have to introduce something else. Sometimes we're interested in functions with only a single argument, okay? Ellipsis is too permissive in this case because ellipsis matches any number of arguments. So I told you that ellipsis is kind of a placeholder for any number of things. What about a placeholder for one thing? We have that. It's called a metavariable. A metavariable is a placeholder in Semgrep pattern which matches exactly one thing. It could be one argument, one expression, one identifier, anything like that. But you can put it anywhere that you'd expect, quote unquote, one thing. And we're going to go based on vibes for what that means, okay? But let me show you how that looks. So the syntax for a metavariable is a $sign prefixing a capital identifier. So $x is capital X is one, capital $X is one. Usually you can put it anywhere that you could originally put an identifier. So if an identifier, like a name, like foo or bar, is admissible, usually a metavariable also is. So by that logic, I would like to show you how we would actually write a Semgrep pattern that matches like any function. And let me put a few functions for you here actually, so that works. So like let's say we have a function bar that has like one argument. I told you that this does not work, right? This does not compile. It doesn't parse. But what looks like a function? Well, let's start from scratch, okay? Semgrep rules look like patterns. So if I wrote literally the same code as this function here, I can match and it would work. It would work to match here. But this is too specific, right? I wanted to match both. So let's go and look at it. Let's take the identifier, and let's say instead of foo being the identifier, let's factor it out. Let's replace it with $func, a metavariable, a placeholder for any identifier. And then this pass, well, sure, I can have the body be a pass. That will work. It will match this, but it won't match here because we have only one argument as opposed to any. So we might also put a ... here. So we say any number of arguments, any function name, and we'll match both. But what if the body is not pass now? What if the body is like return 1, and the name of it is cooks and takes in 2 arguments? Well, now this is not going to match, right? Because we said any argument, or any name, any number of arguments, but only if your body is pass. So what could I put here? What do you think I'm going to put here to make it so any body is okay? Any function body is okay for us to match. Instead of pass, what I should put is something that specifies any number of things, perhaps anything. What do you think? Wildcard. Well, there's two kinds of wildcards, but I guess what you mean is like ellipsis probably, which will be exactly correct. Correctamundo. If I put a ellipsis over here, it will match any number of things. Anything. And so this will let us match all 3 of these things. 3 matches. Okay? I hope that this like kind of incremental way of writing this pattern makes sense to you. Like this is like how I like to think about it. Is like we kind of slowly factor stuff out until we get a general pattern. Prochaska, you have a question about dollar $expert. This is a meta variable. Sorry. Dollar expert, not dollar func. Yes. Dollar expert, I believe, actually also works in this position, but it would only match functions that had a single item in their body. So for instance, if this was like, cooks, but instead we had x equals 2 right before, and maybe we return x, this would actually not match. Oh, huh. I think there's some magic going on where Semgrep knows what you mean, and Semgrep knows that you mean like not something that literally only has one thing, but you mean like something that has at least one thing. So that's actually, yeah, that makes sense. Okay. So it looks like it actually helps you and matches out here, but dollar expert would work too. So good point. Yeah, good call out. So that's it. That's how we write a general Semgrep pattern. Cool. So I kind of showed you this already, but this is indeed how we write this general function pattern. Okay. I would like to do another exercise together. This exercise is going to be called enforcing secure cookies. In particular, we have this Java program here, and I'm kind of going to bounce between languages here, but like the idea remains the same. Like Semgrep rules are not just for Python, it's for any language that we support. In particular, we have this cookie C, and we have a problem where someone uses a new cookie, and then they call .setSecure on it. And if you call setSecure with false, well, lo and behold, buddy, that's a big problem. Okay, you probably should not call setSecure with false. Can somebody think of a way that I would match? So let's read this again. So okay here means I don't want to match on setSecure of true. Rule ID here means I do want to match on setSecure of false. And rule ID here means I do want to match on setSecure of B, where B was previously set to false. Can anyone think of a pattern that we should write in order to match some cookie dot setSecure of false? What would I write here? Where our pattern is going to look like Java code. How to also find chain commands? Oh, does anyone have any thoughts on what pattern we might write here? This is a bit of a doozy, but the idea is that we want to match a property access on a cookie, where that property access is like a so security cookies test, Ricardo, would help us match this whole function. But we don't want to just match the function. We want to actually just match this specific thing. So this would work also, Daniel. So let's actually try that out. So Daniel, you have a bit more of a particular solution, as in I think you're actually a bit more correct than the one I'm going to propose. But I'll talk about why I'm going to do this one here. So let me take a subset of your solution and work with it. But you're totally, both you and Ollie are totally right. If I call $C.setSecure false, I'm going to get a match here, and no match here. So in this one, I haven't actually, what you've done is you've constrained us to saying that indeed $C is a cookie. That is actually totally correct. The kicker about that is that the range is not going to be quite correct. What I mean by that is if we did cookie $C equals new cookie, ... and then we put in maybe an ellipsis in between. Well, this is actually, this will work, but it's going to match like a bunch of big ranges, which is not quite what we want. So you're correct. You're more correct in the sense that we should constrain $C to be a cookie, and there are other ways of doing that we'll talk about next week in advanced rule writing. But for now, let's work with this one, where we're going to say, if you call .setSecure on anything, okay, and you do it with false, where $C in particular in this case is a cookie, probably you made a mistake, buddy. Okay, and we should be able to see that on line 18. The reason why this works out well, the reason why it's okay that this works is because, again, Semgrep is kind of smart, okay? And it is able to understand via constant propagation that this B that is set to false actually makes its way over here to this. Yeah. Actually, I kind of wonder, this is how you negate in Java, right? Yeah, let's go. I love it when Semgrep does cool, smart stuff. So Semgrep does some constant folding. Cool. If this makes sense to everyone, this is kind of one way that we could write this rule. And tomorrow we'll talk about, or next week, we'll talk about other ways that we could constrain this $C to truly be of type cookie. Okay, which is actually a really interesting use case. Okay, and then we have one more, yeah, we have like one more thing, which is, I'm not going to ask you to do this actually, but let's suppose that we're doing request.get in Python, and we want to find when people use it insecurely, which is that Semgrep evaluates the Boolean, but like not by running your code, but because it's like smart and it does it like by simulating it. Let's suppose that we're doing request.get, and if you pass verify equals false to request.get, like you got a problem, buddy. That's a big issue. So we're gonna slide along here because we lost some time. But basically, the idea is this is what you would write. You would write request.get, where one of the arguments is dot dot dot, meaning any number of arguments can appear. Then one of the arguments is verify equals false. Then the last argument is dot dot dot. What this means is that any number of arguments, including 0, can appear before the verify equals false, and any number of arguments, including 0, can appear after the verify equals false, just so long as verify equals false is somewhere in there. And if I run this rule, it's going to match here where there's a verify equals false. It's going to match here where there's a verify equals false, but not here where there's a verify equals true, or these two cases where there's no verify at all. Okay. I didn't really talk about using ellipses with other arguments, but like this is pretty much how it works, is that you use it in place of a single argument. So dot dot dot, and then followed by a comma, because this dot 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 is substituting for a single argument. But Semgrep understands that you really mean like it's going to consume multiple arguments. Okay. Hopefully this makes sense to everyone. But this is kind of what I mean, where like if you know how to write Python, you can use your best guess, and probably it's going to be able to write this pattern for you. So I think that's pretty cool. But yeah, nice. Cool. So I wanted to talk to you a little bit about pattern operators in our last like few minutes here. Actually, it turns out that I'm gonna a little bit run out of content, but I'll cover most of the stuff I wanted to. Usually when we match something, we have multiple things we want to match. Like either we want to match like multiple things, as in one of several things, or we want to match something that fulfills many conditions. So one of several things or all of several things. There's a few operators which are patterns that combine other matches. Let me just show you what I mean by that. So for instance, if I had a call to exec and I had a call to, I don't know, like print here. If I wanted to match just the call to print, I would write this pattern that I showed you earlier, right? But let's suppose I wanted to not just match calls to print, I want to match calls to exec. I haven't showed you this, but in structure mode, which is our UI for writing rules, you would use this any operator, which says to match when any child patterns match. So this any says to match print, or it means to match exec. Okay? So if we did this, we would be able to match both, because this any is really an or. It means match when any of these children patterns match. Okay? That should hopefully make sense. Like this is our way of doing it without needing to write any syntax. You just use the UI. All is different. All means to match when all of the children patterns match, which means that we're not going to match anything from this, because how can something be both a call to exec and a call to print? Okay, so all is used for slightly different things, but any is used when you want to match one of several possibilities. Any operates under set union rules, which means that if the blue were to match something and the red were to match something, your total matches are going to be 2. It's going to be the set union of the 2 matches. Okay. Whereas, so for instance, in the actual rule and target, it would turn into this, would be our final match. Whereas all operates under set intersection. So if blue matches blue and red matches red, the intersection, like the literal range intersection of the blue and the red, is nothing. There's no space in common with both of them. If you look at like the ranges, again, the ranges that they cover. So in this case, we would see that we would result in no matches, as I just showed you. Okay. The all operator is useful when you combine it with not, because what you can say is, for instance, you could say all function calls that are not calls to print. Let me show you what that looks like in the UI. So instead of doing this all here, I could say any function call. That's what $func dot 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 means. Actually, let me show you this incrementally. So if I did all where I have one child, which is any function call, it would match both of these. But now let's suppose I only want to match the print, or only match the exec. I'm going to use what's called a not, which says remove findings matching this pattern. The UI looks a little wonky because I need to do that. Not, and then under the pattern, I would write specifically calls to print. So not is used in conjunction with all to remove findings, is the idea. If you don't want to have a certain finding. I would do that a little bit differently, Manu. If I wanted to match a parent function that called both print and exec, here's what I would do actually. So let me spin this up. I'm going to probably end really soon, but basically here's a function foo that calls none. Here's a function that calls only print, and here's a function that calls both of them. Print exec. What I would do is I would do this. I would do one pattern, which is def func, where it contains a call to print somewhere. I don't know where. And I would do another pattern that is just a pattern and I would do where it contains any call to exec. And the all is going to enforce an intersection. So we should see that we only match this, right? Because if we look at, this is another really cool thing you can do. If you hover over this, it will show you what this particular subpattern matched. So this thing looking for calls to print matched this. Turns out actually that there is probably if x equals 1 here. It should match both of these, but maybe there's some kind of UI thing going on. But the idea is like we look for things that have it's reverse is what it is. Sorry. We look for things that match exec and for things that match print, and only something that has both survives. If that answers your question. But hopefully that makes sense. But that's kind of what you'd use all for, is to match something that has two conditions that's true of it. Okay, really, really fast. I'm going to show you this very last. Oh, actually, there's two last ones, but I only care about this one here. I'm going to show you this order of API calls must be enforced exercise, and then I think we'll end. So I've got like some code here where I'm in a financial trading application where I have calls to this function called verify transaction and this function called make transaction. I want to make sure that verify transaction is only called before make transaction. If make transaction is called without a verify transaction, that is bad, bad, bad. Okay. So what I'm going to say is I'm going to say, I'm going to just do this in front of you. First, let's decompose the problem, right? Let's match any function call that has a make transaction in it at all, right? And then we'll worry about removing the false positives later. So we'll do public void func takes in any function or any argument, and then somewhere in it has make transaction. So if you do this, remember we want to call verify transaction first. We're going to match all of these. So we're going to have a few false positives, okay? But this one is bad because we just called make transaction. This one is bad because we called make transaction before make verify. This one is also bad because verify was called after make. So on and so forth, right? But now let's remove the case where verify is called before make transaction. So I'm going to add another condition. I'm going to use not, and I'm going to say, let's remove the case where we have any function, but verify transaction is actually called before. We want to remove the verify before case because that's the good case. Remove the good cases, okay? And if I run this shouldn't match because we verified before we make. There's no verify, so this is bad. There's make before verify, so this is bad. There's make before verify, so this is bad. There's verify before make, so this is good. And this one, finally, is actually, this is a different thing where we would have to ensure that they're called on the same transaction. We can actually do this if we said this, I believe. So the problem here is that we make a different transaction and we verify a different transaction than the one that we make. So we want this to be a match. And if we add this condition here, we use our metavariables. Metavariables actually unify. So if in one pattern you use $t 2 times, you actually mean that these $t's are the same. Okay. Hopefully that makes sense. We are just out of time here, folks. So I don't want to keep you longer than we said this webinar would. Thank you all for coming. I really hope to see you next week in 201. We're going to go for the big leagues. We're going to get real advanced with it. So thank you all.